Welcome to use case number 9. As a part of this use case, we will try to create a RESTful microservice with Spring Boot and Hibernate. They will interact with a MySQL database. As you can see, container 1 runs MySQL and container 2 is a web container running Spring Boot and Hibernate. We will use a RESTful client such as Postman or curl to make the RESTful calls and test a microservice. So let's see how that can be done. Now let's open Visual Studio Code. Let's navigate into use case number 9. As you can see, I have use case number 8 open as well. This use case has basically a YAML file and it also has a Java project. So let's go through the YAML file. The YAML file, as you can see, the first version is the version of Docker Compose, as we saw in the previous use cases. We're going to run two microservices, one called MySQL, which is going to download the MySQL image. The next one is ports, which basically says expose this as a port on the host machine. And the host name is basically MySQL. We basically provide the user name and password for the root account. You can basically change it if you're using this in real time. We also have a web microservice, which is called Pictolearn Docker, runs on port 5555. As you can see, it's mapped to port 8080 of the container, and the host name is called web. The TTY is true, very similar to your Docker build command. Now I've commented this out. I recommend that you take care of this or experiment with this particular tag on both the Windows and on the Mac. And if you have questions about volumes, go back to the use case where you learn about volumes. So this is a to-do for this class. It depends on MySQL, which means the container is going to start this first and then look at this. And then it's also linked to MySQL, which means that when you run the Java program, you're going to refer this with MySQL as the host name. And remember, this can also have an alias name called my-SQL or something like that, which is easy to read. And either ways, I'm not giving the alias, but if you give the alias, you need to basically refer that in the program. And then I basically specify an environment variable, which is not really required. So this is just to demonstrate the use of environment. So that said, let's import this particular project to Java. Before that, I also want to show you, open the Pictolearn Docker and show you the Docker file. The Docker file is very simple. It basically gets an image from Pictolearn Ubuntu JDK 8. If you're wondering where you got this image from, go to use case number 8. And then if you look at the Docker file here, it basically is running Ubuntu 16.04 with Oracle JDK 8 installed along with Maven. So we're going to use this image. So if you are experimenting with this, make sure to correct this particular Docker file, which is basically going to get the respective image. Now this image will need to run on any Linux version with JDK 8 and Maven installed. So that's basically the high level. And then what we're going to do is we're going to move this project as is to this particular directory and then run Maven on it. And this is how you start Spring Boot. It's basically java-jar, and then you provide a log path, and then you also map that particular version of the jar which Maven is going to create. So let's take a look at the Java project. Now what I'm going to do is I'm going to copy the path to this particular project, which is nothing but the Java project. I'm going to open Eclipse. And then I'm going to say import existing Maven projects. I'm going to just copy paste this, click on finish. The next thing I'm going to do is to open it. As you can see, we have the Docker file here. The Eclipse has the Docker plugin installed, so it's looking very legible. Just keep a note of this particular image. As I mentioned earlier, it's got JDK 8 with Ubuntu and Maven installed, and add it to the path. And we're adding the whole project to the path, and we're running Maven and with java-jar, and this is how you start the Spring Boot application. You can as well try it out on the local. If you don't want to use Docker Compose, feel free to try this out on local. The only thing is MySQL will not be started, so that's the only deficiency here. Other than that, it also has a scripts folder, and the scripts folder basically talks about JSON. So just open with text editor And then as you can see, this is how the JSON is going to look like. It's going to have a name and an email, possibly an ID as well. And then this is an example of the curl command in case you need to use if you're using Mac. And it also has the SQL file, which basically gets generated, but you really don't need to do this. We're just going to create a table called users, and then with the name and an email and an ID, which is the primary key. That's the goal of this microservice, to be able to create a user table. And so let's take a look at some of the things in Spring Boot. So as you can see, the first and prime Java class which is going to get executed as a part of this Java file is going to be application.java. So if you look at the pom.xml, I've included the versions of Spring Boot and MySQL. So this particular series is just going to be a quick overview of what we are including in the Maven project. So as you can see, I basically have Spring Boot Maven plugin, which is very important for you to run Spring applications. And then we also have the mysql.jar. We have all of the packages required for Spring Boot to function. I'm using release 1.4.1 release, but if you have a later version, feel free to use that. We're also using JDK 1.8, as you can see. And then, so going back to the first class, this is basically the first class which gets executed. And as you can see, this is using JDK 8 Lambda functions. And we're going to go to controller. Now this is the RESTful controller. As you can see, there is a delete method. You can delete it using an ID. You can list all of the users. We can add users. So it's basically got all the CRUD operations. So creating, deleting, and listing for now. This basically has user DAO, which is auto-wired. So what we're going to do as a part of this DAO is it's just going to create a session factory. For those of you who don't know Hibernate, you should experiment with this simple class just to get an understanding of Hibernate. Now, a lot of people use Ibatis or other ORM tools, but this is just a example for you to learn from. So as you can see, the user DAO actually has a getAll method, which is going to query the database for all the users. There's also one other method called getByEmail. I've just added it in case you want to expand this RESTful controller. And then there's a getById, and there's also an update. And there's also a save method. So I'm just going to put annotations in here when I check in the particular series to Git for better understanding. And then we have the user object, which is nothing but the ID, email, and the name. As you can see, it's got some limitations on what you can enter. So just be aware of this particular limitation. The minimum is 2, maximum is 80. And then we have a database configuration, which is going to take in the username and password. So it reads all of these parameters from application.properties, which is in source main resources. As you can see, we have an app name, app description, path to the logs, and then we also have a driver for MySQL. We plug in the username and password for the root. If you notice here, the host name is MySQL. Now, in case you change the Docker Compose file to have an alias or something like that, in case of links, then you will need to basically go back and then change this particular host name. There's also log4j2.xml. We're using log4j2. It's going to log to a particular path. So all said and done, we are going to go back and execute this. Since this course pertains to using Docker, I have not focused much on the working of these particular aspects, but I'm assuming that since you're all Java engineers, you're going to catch it up. Just note that you can play around with this program after downloading it from Git. The exercise here is to do a add, list, and delete of users from the table. And as you can see, the user is going to look something very similar to this. And then here I'm saying create and drop. So what it's going to do is every time this container starts up, it's going to drop the table and create a new table. So you don't need to execute any scripts. You can basically change this to update, or there are other possible values for Hibernate, but just understand that it's just going to create and drop. All right, so let's go check it out. The next thing I want to show you is also to be able to install a RESTful client if you're not so comfortable using curl. So you can get Postman, which is a REST client. So the instruction of this is pretty straightforward. You can also get a plugin if you're using the Chrome browser, or else you can get the complete installable from one of these versions. So I highly recommend this. It's free. It allows you to test all the RESTful calls with session in case session is turned on as well. So there are other clients which are Insomnia. So you can just say REST client, and then you can get Insomnia, which is also a free client. There's one called Paw, and Paw basically is only available for the Mac, but it's also a RESTful client. This one is in particular is paid. So I recommend using REST Postman. So in case you're not familiar with using curl, if you're using curl, then good enough. So that said, I think I've covered all the installation and introductory part on what is required for this use case. So in the next lecture, you're going to see how this is all going to fit in. Thank you for watching this lecture, and I look forward to seeing you in the next one.